Hello children, hello everyone. See, last few classes we understand what is atmospheric refraction. So this natural phenomena, it will be happen because of the atmospheric refraction. So what is that phenomena called? We can see advanced sunrise and a delayed sunset. Okay, this effect is because of the atmospheric refraction only. Sorry. See, why we are going to see this? See, actually, the sun. Okay, so let us imagine this is the Earth, and the sun. What is? Suppose it is the origin of the Earth. Before 2 minutes only. Okay, before 2 minutes of sunset. Suppose imagine at 5:30 sun is going to set at 6 o'clock. Before 2 minutes only, we are going to see the sun, and even after 2 minutes, suppose sunset is at 6. You just imagine before 5:59, 5:58, like that, we are going to see the sun. And after 2 minutes, after 2 minutes also, we're going to observe the sun. Even though it is sunset also, after 2 minutes, we're going to observe this. And before sunset also, we can see the sun. So why this will be occur? That means advanced sunset. Before only sun rises, no? Before that, we're going to see the sun. And delayed sunset. Even sunset also, after 2 minutes also, we can going to see. So why this 2 minutes delay and 2 minutes advance? That will be because of atmospheric refraction. As you know, and we will go above the altitudes, we will go higher and higher altitudes. What happens, children? The density goes on decreases. So that means this area is rarer and this is denser. Compared to first and second, you will take this is first and second, this is rarer to denser. Again, you take this is first and second. Again, this will act like a rarer and it will be act like a denser. Okay, if you take this is 1 and 2. Like that, it will keep on changing. Density from rarer to denser is ray will always try to suppose imagine these are the different rays. So you just imagine this are normals. Now how the ray will come? The ray will be keep on coming from rarer to denser. So when it is coming from rarer to denser medium, what happens? Rarer means more less traffic area to more traffic area. You can just know when your bike, or imagine your bike or cycle, it is coming from less traffic area to more traffic area. What happen? Your velocity or the speed, it will goes on decreases, and your speed is decreased. That is why instead of going in this path, it will be bent towards like this. Again, it is coming from rarer to denser. Again, it will go to bend. Again, it is coming from rarer to denser. It will bend like that. Here, see here. The light sun is actually the here. This is the actual position of the sun. But because it is bending when it is from rarer to denser, instead of going in a straight path, see at every contact surface, it will keep on going to bend. That is why we can see the bending of a light. So when the light is coming, bending and coming, but what light appears? It is appears like a rectilinear property, that is straight line path. So it is appears to coming from where? It is appears to coming from here. So this is a apparent. Okay, this is what we call apparent position of the sun actually. So how it will be apparent position? Let us take one bowl. Okay, inside one container, let us take a glass one, and put one coin inside. Okay, fill initially you see the coin, it will be actually depth of, let us take 2 meters. Okay, 2 centimeters height it is looking. Once you fill this with completely with the water, so that time you observe the coin will not be this. This is the actual position of the coin, but it won't be here. But it is appears to coming from where? Coming from little top. The bottom, entire bottom is appears to be at this height. It is by outside you can see it is only view like a 2 centimeter height, but you can see through the water you can view it is like 1.5. That means that's all. That means actual height in apparent height and actual the positions are different. Here also because of atmospheric refraction, actually it is far, but it appears to coming from above the horizon. The sun is below the horizon. It is not the sun rises also, but before sun rises, only 2 minutes before only we can see the sun because of atmospheric refraction. Are you understood, children? Why? Similarly, sunset also. If Earth is there, okay, this is the sun. Imagine if the sun, even though already it is down the horizon already, okay, sun is, this is the actual position of the sun, but where it is appears to coming from here, sun is light ray is trying to bend. Okay, because of that bending of light, it appears to coming from above. Okay, that is why after sunset also we can see, after 2 minutes also we can see the sun. Clear, children? This is what we call advanced sunrise and delayed sunset because of the atmospheric refraction. Okay, because of atmospheric refraction phenomena only. I hope this is clear to everyone. Let us see another property. Okay, so other properties, apparent position or twinkling of the stars. Why we can see the position of the stars is also changing. They appears to coming from less distance or more distance. Okay, and the twinkling of the star also we can see here why the stars will going to twinkle, but why not the planets? Okay, that we'll see in the next line. But now see how this twinkling of the stars and apparent position of the star varies. This is again because of atmospheric refraction only. See, this is the actual position of the star, it is there here. This is the actual position of the star. Because of atmospheric refraction, instead of light going a straight path, see, it is appears to keep on going to bend when it is reaches the person who was standing on the earth. When we see, no, it appears to bend. Okay, that is what we can see. This appears to bend, but actually, where light is coming from? Actually, light is coming from this position. This is what we call apparent position. What we are seeing from the earth, no, because of atmospheric refraction, actual position and apparent position changes. Like shift in the position of the star, we're going to see. This is what the shift in position of the star because of atmospheric refraction, what we call as a apparent position of the star changes, and the twinkling of the stars. Okay, why the stars will going to twinkle? The ray of light coming from the stars. Okay, because stars are very far distance from us. Only few light is coming from the star. Out, suppose it will emit 100% of light, in that only 1% of light will come to reach us. Because that 1% of light also what happens? Suppose there is a any obstructing particle. Atmosphere is made a composition of different gases. If there is a one particle, it is going to absorb the light, or sometimes it is going to scatter the light. That time we cannot see the light. So when we see the light, there is no any path, any particles in between medium. So you know the air, your earth is circulating about the axis, the air is also circulating. That is what we can call atmosphere is also circulating. Because of this things, it is not uniform atmosphere. Atmosphere is keep on varying. So because of that, the path of light what is coming, it is also keep on varying. Sometimes it will off light, that means not reaching us. Sometimes we can see the light, and sometimes it will going to more refract or less refract, like that. The changes in the path of the light will going to happen. The change in the path of light, what we call as a twinkling effect. Clear, children? What is the called as a twinkling effect of the star? The apparent position is appears to be at some other position. It's the actual position of the star is here. Okay, but because of atmospheric refraction, light is keep on going to bend when it reaches this person. So because of that, star is appears to be here, and that is twinkling because of it need to cover more number of the layers of atmosphere. Okay, because it's very far from the earth. Only few portion of the light from the star is reaching us. Even that light is also just oscillating. Okay, that means not coming straight. Suppose you just taken one dim light, is a damaged light, it will continuously on and off. What you see, your eyes will get pain, and it will appears like a twinkling effect. You can observe there. So like that we can see the stars are twinkle. Clear, children? Why stars are twinkle? Because of atmospheric refraction. Okay. And the next effect is the planets, they do not twinkle. That is what we can see the night sky. Some after, if you at a sudden we can see, we cannot identify, but we can see 2 to 3 minutes you observe some objects will not twinkle, but some objects they keep on twinkling. Okay, that means the shapes, color are there twinkling, and these are not twinkling. Which are not twinkling, we can observe the size also little higher. They are called what I call as the planets. The planets we are nearer. Okay, suppose it is the Earth, the planets are very near, the stars are very far from us. That is why only few light rays will coming from that star to reach us Earth. That is what with that light rays will going to path changes and any atmospheric diffraction. We can see that twinkling effect here. But because the planets are very near to the Earth, very near to that, so much rays, okay, so many rays are coming because of that refracted rays from the sun. There's so many rays are coming to reach us. That means so many rays are coming. No, all the rays at a time they won't undergo refraction. Okay, 1 or 2 rays will undergo refraction also, they will going to neglect. So that we cannot see the twinkling effect here. Okay, amount of light getting is that is very high. Okay, amount of light getting because of this size is distance is less and size is also more. Okay, when you see far star, very the size is very less. Only few rays are coming from here. Here more rays are coming. No, that twinkling effect is from this way and this way cancel out, and which are coming straight that we can see easily. So that twinkling effect is not there for the planets. I hope this is clear, children. And next, why we can see the sun is a bigger during the sunset and the sunrise, okay, or disk shape of the sun. Why we going to see? That is because our moon or sun also, when they are at a suppose this is the earth, when they are at the zenith, we can see smaller sun. But when they are at the equator, you can see some oval shaped sun. Okay, some oval shaped, and it is bigger in size compared to the when it is at the zenith. When it is at the zenith, what happens? It will come to the rays from the sun comes normally almost, so that we cannot see any refraction. More number of refraction we cannot see here. Okay, less refraction, so that we can see size is the actual size only. But when it is coming from the denser the horizon position, it need to cover more amount of a distance, and the ray need to come like a bending manner. So because so many layers it need to cross and come, and the same time the optical distance what it will cover, right children? The optical distance it is covered more here, because to cover more optical distance it is appears is actual position and apparent position. It is actually here position, but it appears to be very less. Suppose if we take this as earth, the actual position is this, but it appears to apparent position is very nearer to the earth. That is why we can see sun size is this, but we can see size of the sun is bigger. Okay, that is because of optical density. We need to cover more optical medium, so that it appears to more apparent distance is very less from the earth. That is why we can see bigger size in the evening and afternoon. Sorry, evening and morning times. If the sun or the moon is low above the horizon, that means below the above the horizon, but very low. Okay, the optical path of the light through the atmosphere is very long. Thus, refraction is also maximum refraction we can see here, but here it is a minimum refraction, and this horizons we can see maximum. Because of maximum refraction, the size will be appears bigger and lesser distance. Hence, apparent image of the sun is very much closer to the eye. Thus, the apparent is appears bigger in size. I hope this is clear, children. And the next is the same, the flattening also, apparent position one thing, and the next thing is that flattening. Why we can see the sun is almost flattening, you can observe this figure actually. See, actually it is there with the down this much. Okay, instead of a round shape, we can see at the down it will be flattening surface, we can see. So why this much of portion we can see it is not there. Okay, because of this atmospheric refraction phenomena, again we can see the flattening of the sun or the sunrise or sunset, but circular at the noon. In the noon we can see it's almost circular sun, but evening and afternoon flatten. This end will be flattened, right? That is because of atmospheric refraction. The sun near the horizon, rays of light at the upper and lower edge of the sun bend unequally while traveling through the atmosphere. As a result, this phenomenon, the sun appears like a oval or flattened. Okay, at the noon sun is overhead, no? The rays of light enters the atmosphere normally. Okay, they will come normally in any ray. Suppose you learn in case of mirrors, any ray which is coming normally, it will traces in the same path. That means there is no any much deviation. When it is coming this angle only, that time it need to bend. Okay, so that sun appears a circular shape in the noon. Okay, in the noon it will be circular shape. In the sunrise and at the sunset, what will happen? It will be oval and flattened because of atmospheric refraction phenomena again. I hope this is clear, children. Yeah, the last concept is a mirage. What is this mirage called? Okay, so mirage you can observe in case of deserts. In case of deserts, why we call desert? The temperature is very high. When temperature is high, the air will be very hot. Because of that hot air, what will happen? Density is very less. Because of less density, the ray will go faster and it will refract back. Okay, at the low level of atmosphere, the ray will come here. It will fall again. It will totally internally reflect back. So this reflect back, no, the sky, whatever there is sky, that will be the shadow of the sky will be falling on the earth surface. That is what we can see. The water surface will be present here. You can see here the tree. So the tree shadow of the tree is falling down. That means what we can observe here, water is there. Inside the water, the shadow is formed. But it is inside the water, shadow not formed. That is because of mirage effect it is formed. So why mirage is formed? See, water, warm air is less dense than the cool air, and the difference between just a second. The difference between them creates a gradient in the refractive index of the air. Okay, changes in the refractive index of the air. So light from the sky at a shallow angle, that means what we call at a critical angle we call, actually in physics we'll understand that later. Okay, to the road is refracted, making it appears as if the sky is refracted back to the road surface. Here in the second figure we can see, no, the sky shadow is forming here. There is no water in the desert, but it is appears. That is what we call optical illusion. Okay, making it appears in the sky reflected back to the road, and the mind interrupts this as a pool of water on the road, as a water also reflected back to the sky. Water is also reflected back to the sky sometime, and the sky is also reflected back to the earth. That is because of critical, when light falls exactly at the critical angle, it will reflect back completely. Okay, this effect what we call as a mirage. Okay, children, this effect we can see in case of deserts, we can see, and very hot climates. In case of summer, we're going to observe this mirage effect. On the roads, we can see here, no, when we're traveling in case of summer in a big highways, that time we can see the reflection of the sky is falling on the road. That is what we can see, the surface is like a water, but there's no water, but it appears. Okay, our mind interprets this as a pool of water. This is what we call mirage effect. That is because of atmospheric refraction, and also one more reason is also there, that is total internal reflection also. Okay, both this phenomena leads for this mirage effect. Okay, children, I hope you like this video. Thanks for watching. Please subscribe my channel if you like this video. Thank you for watching.